Right, there's 30,000
When this
feet.
goes to vacuum, imagine all the pounds forcing on this. Every inch is 15 pounds pushing. That's why this is number of inches
So
thick.
the Air Force requires a spacesuit when you pass 50,000 feet. We just passed 30. At 63,000, that's the point more or less at which basically there's 40,000, where basically something like your body fluids would boil at room temperature when we pass 60,000. So we just passed 40 and we're on the way up. And that's really, when people talk about spacesuits or pressure suits, they think about the lack of oxygen, but it's really the pressure that would get you in, well, particularly nasty ways. 50,000 and coming up.
So right now you have to have a pressure suit in there to stay alive. You fed oxygen before, okay, but now you have to have a pressure suit.
Right, and on the way up. Where we'll really start to see the changes in the water will be north of 60,000 feet. There's 60. So when we talk about water boiling at room temperature, really what we're saying is that if the liquid was as warm as your body, say 98 degrees, it would already be boiling. That water was at room temperature here, so it'll probably be 70 or 80,000 feet before it comes out. There's 70. And you can actually already see there's some bubbles turning up in the water now. They're just beginning to start. It's like a pot, it's just starting to boil. So there's 70,000 feet. And this is just room temperature water. There's nothing special about it. The marshmallows are less interesting than I was expecting.
Yeah. The water's moving now, though.
Yeah, the water's starting to move now.
He's like cranky so the marshmallows do something.
85.
Okay, so there's 85,000 feet. There was so much, when you start running these for the first time, you find yourself going back to high school physics and saying, wait, why is stuff happening? And right, so there you have boiling at room temperature. 90,000 feet.
So that would be the blood in the body. Then have to see that.
Right, so that's really if you really want to know what the suit's protecting you from, it's keeping your blood from doing that.
I think those marshmallows are an indication we shouldn't eat
One of the
them.
things that really surprised us, though,
Good point.
was that
They
even
didn't
as you're
change
going up,
hardly
you
at
can actually
all.
see a slowing in the boiling, and you're saying, well, why is that? Well, the boiling is reducing the temperature of the water. So you actually get a reverse cycle here.
The evaporation, actually, you'll see the evaporation increases and drops the temperature of the water now quite a bit. And then you start to see the
Right. Right, so, and somewhere in just a little bit here, we'll be looking at both the combination of where the water's boiling, but it's also cooling rapidly at the same time.
Oh, that's cool.
Right, so, so you sort of have for right now, you sort of have a situation where the two things are going back and forth against each other, where it's cooling rapidly, but it's also showing a drop in pressure around it. And our rate will slow down a little bit.
110,000.
110.
And then it's gonna freeze? Is that what you're saying?
That's freezing.
That's far
You
out.
see how rapidly it goes, and you can actually see it.
It's like boom, just all of a sudden.
Wow.
Whenever I tried to explain this to people, I was sort of looking at looking it up, and they were saying that water's a weird substance because it can be just a fraction of a degree between freezing and boiling. And so that's why you actually can see some boiling under the ice there. And when we did this the last time, I don't know if we'll get any this time when we take it back down, but you actually can have bubbles that have frozen as they were boiling. So there you are.
So the triple point is where you have all three in equilibrium. Now we passed that because
Yeah.
we're